Okay, you can pause the video here and do your corrections for the MCQ first, okay, before I proceed to explain all the answers. Okay, now I'll start with question 1. Question 1 asks which of these chemicals is a salt. Remember, a salt is just an ionic compound, okay, that is formed by replacing the H plus of an acid with a metal or ammonium, okay, ion. So only potassium chloride C will satisfy that definition. Ammonia is a gas, NH3. Methane, CH4, is also a gas. And your sodium hydroxide is a soluble base or alkali. Okay. Question 2. Metal react with acid to produce salt and hydrogen. This is from your acids and bases chapter. Question 3. Insoluble base neutralizes an acid. Okay, this is actually an insoluble MCB plus A salt preparation method. How do you remove the excess base? Since it's insoluble, you can just filter it. Okay, why do you filter it? Because you're trying to remove it out from, separate it from the, okay, the aqueous salt that you form. Okay, for question 4, which of the following salts can be crystallized from an aqueous acid? In other words, it has to be a soluble salt. Okay, because if it's an insoluble salt, there's no need to crystallize it. Okay, and since crystallization, you're crystallizing it, it has to be from insoluble MCB plus A or titration reaction. Okay, but if you look at options A, B, and D, they are all insoluble salts. Answer has to be C, which is a soluble salt. Question 5. Which of the following pairs of substances are the most suitable to be used to prepare copper 2 sulfate? Copper 2 sulfate is a soluble non-spar salt, which means you need to use insoluble MCB plus A. I can eliminate B and C because they are not using insoluble MCB plus A. I can eliminate A because copper is unreactive. Answer is D. Question 6. Solid S has the following properties. 1. Yes, insoluble in water. I can eliminate C and D because D is sodium hydroxide, is an alkali, is soluble in water. And C, potassium carbonate, is a soluble salt because it's spar salt. Okay. Next, part 2. It produces a gas when heated, and 3 produces a gas when added to dilute sulfuric acid. If I look at option A, calcium oxide, okay, is a base. When it reacts with sulfuric acid, it will only form water. It doesn't form a gas. Answer has to be B. Okay, copper 2 carbonate, when it reacts with sulfuric acid, it will form carbon dioxide gas. Okay, because it's acid plus carbonate reaction. Okay, what is a gas form when it's heated? Okay, if I heat copper 2 carbonate, I actually produce copper 2 oxide and carbon dioxide. Okay, carbon dioxide is the gas produced. Okay, question 7. Which of the following pairs of aqueous solution produces a precipitate when mixed together? Which means I will need 2 aqueous salts. Okay, and one of the products must be insoluble. Okay, so first I will check for whether or not both reactants are soluble. So for A, potassium chloride soluble, barium nitrate soluble. B, okay, actually in fact, if you check, every single reactant is soluble. Okay, but if you look at D, notice that they are both nitrates. Since they are both nitrates, there's no reaction that will happen because even if you exchange partners, the products are the same. So there's no reaction happening. Okay, next I will check whether or not one of the products formed is insoluble. So if I have potassium chloride and barium nitrate in A, I will form potassium nitrate and barium chloride. Both are soluble. If I look at C, okay, I have potassium nitrate plus barium chloride. I'll get potassium chloride and barium nitrate, both soluble. Answer has to be B, which is sodium sulfate plus barium chloride. I'll get sodium chloride, which is soluble, but barium sulfate is insoluble. Okay, question 8. Which salt is prepared by titration by reacting a carbonate and an acid? In order to use titration, you need a soluble carbonate as well as a salt, and you will produce a soluble salt. And remember, acids are always soluble by definition. So answer is A, where everything is soluble. Question 9. Which of the following combinations of reactants is the most suitable to prepare the given salt? Okay, first we check the salt to be prepared. Okay, you notice that, okay, lead 2 chloride is insoluble, zinc carbonate is insoluble. They need to be prepared by precipitation, so A and B are out. Okay, C. magnesium sulfate is soluble, and D, copper 2 chloride is soluble. Okay, which means you will need insoluble MCB plus A because they are non-spar soluble salts. C is wrong because magnesium nitrate is soluble. So answer has to be D, where you use insoluble copper 2 oxide and hydrochloric acid. Okay, so it's insoluble B plus A. Question 10. Which of these sequences of reaction produces the best yield of calcium sulfate? In this case, the best yield doesn't really matter because only one of the reactions will produce calcium sulfate. Okay, in the best yield, okay? Okay, ignore what I said. Okay, the best yield means that you have to use the most suitable salt preparation method. Okay, so because calcium sulfate is an insoluble salt, you have to use precipitation method to get the best yield. Okay, so immediately C and D are wrong because C is insoluble MCB plus A and D is titration. Okay, so why is B wrong? Because B is mixing two solids together, it doesn't work. Okay, so answer has to be A. Okay, but what is actually happening in A? You're adding dilute nitric acid to calcium carbonate. The reaction is here. So you actually first form calcium nitrate, which is soluble. So you get aqueous calcium nitrate reacting with aqueous sulfuric acid. So you are still fulfilling aqueous, giving you solid aqueous. So is calcium nitrate aqueous plus aqueous sulfuric acid giving you calcium sulfate. So you are still switching the partners. Okay, you'll get calcium sulfate, which is solid, plus 2 nitric acid. Okay, so this precipitation reaction also works with acid plus soluble salt. Okay, for your structure and free response questions, for question 1, okay, let's read the question. Cerussite is a lead ore with formula PbCO3. Remember, PbCO3, check for solubility, is insoluble in water. Percentage of lead in 10 grams is measured by the following two-step reaction. In reaction 1, cerussite was ground to a powder and then dissolved in dilute nitric acid to produce a solution of lead 2 nitrate. Okay. However, okay, there is a mistake in the question because remember, PbCO3 is insoluble, so it won't dissolve in the nitric acid. Okay, so I want you to ignore that part and just focus on the reaction part. Okay, so why the ore was ground to a powder, you can just tell me speed up rate of reaction by increasing surface area to volume ratio of the ore. Okay, for those of you who wrote dissolve quicker, okay, I gave you benefit of doubt because that's what the question said. Okay, however, I want you to focus on rate of reaction rather than the rate of dissolving. Okay, because it kind of means a different thing. Okay, especially when it comes to this kind of reactions. Okay. So part B, name the gas produced as the ore dissolved in the nitric acid or reacted. So you have acid plus carbonate, will give you carbon dioxide gas. Okay, this one no issue. Test for gas, you need to bubble the gas through lime water. Do not tell me lime water test is very vague. Okay, so just say bubble the gas through lime water or bubble through lime water. Okay. Next, observation during test, white precipitate is formed. This is from your notes/slides. Do not write any other observation. Okay, your lime water turns chalky was what you use in lower sec. We do not accept that at upper sec or at O levels. Okay, some of you write effervescence is produced. No, okay, your effervescence produced is actually when carbon dioxide is produced in water. That's why you see the effervescence. Okay, so do not write effervescence form for this lime water test. Okay, part C, write a balanced equation for reaction 1, not too much of an issue. I think some of you just forgot to balance the nitric acid. Okay. For part D, okay, write balanced chemical equation for reaction 2. Some of you got it wrong because your lead 2 chloride, you did not write PbCl2, you wrote PbCl. Remember, it is a lead 2 compound. Okay, so stick to lead 2, you will get lead 2 chloride. Okay, so some of you actually wrote an ionic equation where you split the PbCl2 into ions. Okay, remember it's a solid, so it cannot split into ions. Okay, so I think what happened was you misread this portion to precipitate out lead 2 ions as they are asking you for ionic equation. However, what they are trying to mean is the lead 2 ions originally existed as aqueous form when it's part of lead 2 nitrate. To precipitate them out, which means to form a solid containing the lead 2. In this case, is your lead 2 chloride. Okay? So they are referring to the solid. Okay, so do not need to write. Okay, just follow what the question say. Question wants a chemical equation. Give them a chemical equation. Okay, some of you also wrote state symbols even though the question didn't require, and you got the state symbols wrong. Okay, so for those of you who wrote it correct, okay, no issue. But for those of you who got the state symbols wrong, okay, remember if you write state symbols when not required and get it wrong, you will get your marks deducted. So my suggestion is, unless you are absolutely sure of the state symbols, do not write them if they are not required. Okay, for part E, okay, they said the precipitate is filtered, washed, and dried, and has a mass of 8.2 grams. This precipitate is your lead 2 chloride because it is insoluble in water. Okay, using reactions 1 and 2, calculate the percentage lead in 10 grams cerussite. There is an error with the question. It's supposed to be percentage purity of PbCO3 in 10 grams of cerussite. Okay, so I believe most of you got the answer wrong because you followed what the question want, right? Percentage lead. Okay, so don't worry too much. Okay, just listen to my explanation. If you can follow, then all is good. Okay, so to find the percentage purity of PbCO3, I need to determine the mass of pure PbCO3 in the cerussite first. So first, I will backtrack, right? I have PbCl2. Okay, because I want to find the original PbCO3 mass, I will find mass of PbCl2. Okay, use mole ratio to find mass of moles of PbNO32, which is the same as the lead nitrate in the reaction 1, and use lead nitrate in reaction 1 mole to find moles of PbCl3 in reaction 1. Okay, so first I'll find moles of PbCl2, 8.2 grams divided by 278 grams per mole, I'll get 0.029496 mole. Okay, next I will use mole ratio of PbCl2 to PbNO32, and then mole ratio of PbNO32 to mole ratio of PbCl3. Some of you jump directly from PbCl2 to PbCl3. Okay, I give you benefit of doubt, but please write it clearly in the exam because you don't want the examiner to guess whether what you're doing. I know it's all 1:1, but just write it to show the examiner you know what you're doing. Okay, so since the mole ratio is all 1:1, moles of PbCl3 will be 0.029496 mole. Then to find mass of PbCl3, you'll just take that moles times 276 grams per mole. You'll get 7.875 grams of pure PbCl3. To find percentage purity, you'll just take that mass divided by the original 10 grams of impure PbCl3 times 100%. You'll get 78.8% to 3SF. Okay, for the last question, okay, so this is what we call a pH curve or a titration curve. Okay, so what happened was the student added aqueous solution of 0.1 mole per dm cube of potassium hydroxide drop by drop to an acid in a beaker. So the acid is inside the beaker. I'm adding potassium hydroxide into it. Okay, as the alkali is being added, the student recorded the volume of alkali used, which is on the y-axis, and the pH of the solution in the beaker, which is on the the volume of potassium hydroxide is on the x-axis and the pH on the y-axis. Okay, to produce this curve. So, question part 1. Name a suitable piece of apparatus to hold the potassium hydroxide. Remember, it is added drop by drop, so you need to use a burette. Not conical flask, not beaker. Okay, as some of you wrote dropper. Okay, yes, dropper is possible, but because the volume added is up to like 20 cm cube, okay, droppers usually do not hold that high of a volume of liquid, so stick to burette. Okay, part 2. State a suitable method for measuring the pH. Notice that the pH is constantly being measured throughout the experiment. Most of you wrote use an indicator or universal indicator and then checking the color chart. It's not practical to check it because the color will keep changing throughout the reaction. So the easiest way is to use a pH meter or data logger with a pH probe, which tracks changes in pH in real time. And then they will just display it digitally on the software on the graph. Okay. Next, last question. What is the pH of the solution when all the acid was just neutralized? You will have to look at the vertical portion of the graph. Okay, and if you track, it is about pH 7, which is what you learn about neutralization of acid alkalis. Okay, Some of you wrote green, but they want a pH, not the color. So please stick to 7.